Hey everyone, and welcome. Today we're going to break down a clear, step-by-step roadmap to mastering artificial intelligence. This whole thing is inspired by a curriculum for tech students, so think of it as your guide from the absolute basics all the way to building your own AI projects. Okay, let's jump right in.
It's a question a lot of us have, right? We see AI everywhere. It's in our phones, it's in our cars, but how do you actually learn to create it? It can feel like this impossibly huge mountain to climb.
But here's the thing, it's not an impossible mountain. It's a journey, a quest, with really clear milestones and paths to follow. And today, we're handing you the map you need to navigate it. So, our quest begins where all good quests do, by understanding the world we're about to step into. Before we can build the future of AI, we've got to understand where it came from and where it is right now.
What's really fascinating here is that the story of AI wasn't some straight shot to the top, not at all. It started with these huge ideas like the Turing test, but then it hit these long AI winters, basically periods where everyone lost interest and the funding dried up. The real game changer was the 2010s. This explosion didn't just happen out of nowhere. It was this perfect storm of three things. First, massive amounts of data from the internet. Second, super powerful GPUs from the gaming world that just happened to be perfect for AI math. And third, some key breakthroughs in the algorithms themselves. That's what kicked off the AI boom we're living in right now.
So what is AI, really? Well, at its core, it's just about making machines smart, and this breaks down the different levels perfectly. Right now, pretty much everything you think of as AI, your chatbots, self-driving car features, the Netflix algorithm, that's all narrow AI. It is absolutely brilliant at one specific job. Now, general and super AI, that's still the stuff of science fiction, at least for now.
All right, so we've got the lay of the land. Now it's time to forge our tools. Every adventurer needs their gear, right? And for someone learning AI, that gear is a rock-solid foundation in math and programming. You just can't build AI if you don't speak its language. And that language is math. Linear algebra, with all its vectors and matrices, that's fundamentally how a machine represents information. It's how an AI model literally sees the world, but in numbers. And if linear algebra is how AI sees, then calculus is how AI learns. Concepts like derivatives and gradients are the absolute secret sauce here. They let a model measure how wrong it is and then make these tiny adjustments to get better over time. This is the magic behind how machine learning actually works. Okay, let's talk about the practical stuff. Python is, without a doubt, the main language for AI, and these libraries are your essential toolkit. Think of NumPy and Pandas as your sword and shield for wrestling with data. Matplotlib and Seaborn are like your map-making tools, helping you visualize your discoveries. And Jupyter or Colab notebooks, that's your spellbook, where you bring it all together.
Look, data is the fuel for any AI, but raw data is always messy. You have to refine it. This three-step process is so important. First, you clean it up. Then you explore it, kind of like a detective, looking for hidden patterns. And finally, you engineer the best possible features to feed into your model. You've heard it a million times. Garbage in, garbage out. So yeah, this step is absolutely non-negotiable. With our tools forged and our data prepped, we have finally arrived at the heart of our quest, mastering the fundamental algorithms of machine learning. This is where the real magic starts to happen. So machine learning really follows two main paths. With supervised learning, you're basically the teacher. You give the AI examples with all the correct answers labeled. With unsupervised learning, you just dump a whole bunch of data on it and say, go find something interesting. It's kind of like the difference between studying from a textbook versus just exploring a brand new world on your own. Let's zoom in on that supervised path for a sec. It usually boils down to two main kinds of jobs. Regression is what you use when you want to predict a number, like the price of a house or tomorrow's temperature. Classification is for when you want to predict a label or a category, like is this a picture of a cat or a dog, or is this email spam or not spam? Once you get the basics down, a whole new level of cool techniques opens up. You can use ensemble methods, which is basically combining a bunch of models because, hey, a team of experts is usually smarter than one genius. Clustering lets you find hidden groups in your data automatically. Dimensionality reduction is like creating a perfect summary of your data, keeping the important stuff and tossing the noise. And hyperparameter tuning? That's all about fiddling with the knobs to find the absolute perfect settings for your model. Like tuning a radio, you get the clearest signal. All right, now we venture into the most powerful, most talked about part of modern AI, deep learning. This is the tech behind pretty much all of the mind-blowing stuff we see in the news today.
At the very heart of deep learning is the artificial neural network. And the core idea is pretty wild. It's a system that's literally designed to mimic the way our own brains work, with all these interconnected nodes, or neurons, that process information in layers. Now, to build these complex artificial brains, you need some serious industrial strength tools. TensorFlow, which came out of Google, and PyTorch from Facebook. Those are the two giants in the deep learning world. And Keras is a fantastic, super user-friendly library that often sits right on top of them, making your life a whole lot easier. But here's the thing, not all neural networks are the same. They're specialists. You've got CNNs, which have become absolute masters of vision. They can identify objects in pictures and videos. And then you have RNNs, which are the experts of sequence and language. They're what helps your phone predict the next word you're about to type. And of course, with all this incredible power comes a ton of responsibility. I mean, this is so important. As a creator in this space, your goal isn't just to build something clever. It's to build something that's robust, accurate, and fair. Really understanding your tools is key to building AI that works the way it's supposed to and doesn't cause unintended harm.
And that brings us to the final stage of our quest. Knowing all this stuff is one thing, but proving you can actually apply it, that's the whole game. It's time to start building projects and creating a portfolio that really shows off what you can do.
Every hero has their first quests, right? And in AI, these are the classics. Projects like classifying iris flowers or recognizing handwritten digits, they're like a rite of passage. They're the perfect way to apply everything you've learned on real data and get those first crucial wins under your belt. And here it is, the essential gear for any modern AI adventurer. Mastering these tools, from getting free access to powerful GPUs on Colab, to building models with scikit-learn and TensorFlow, and finally showing off your work on GitHub, this is the final step to becoming a truly confident and capable AI practitioner. So, the big question, how long does this whole quest take? Well, the great news is that with real focus and dedication, this entire journey is totally doable. You can go from being a complete beginner to having a portfolio of projects you're proud of in about 9 months. It's an intense journey for sure, but trust me, it's an incredibly rewarding one.
So, there you have it. The path is laid out, the tools are all known, the quest is defined. The only question left is the one that really matters. You have the map. What will you create?